Hello. So, in the last lecture of API 574 code, we have seen some few experts. That is, in section 11, we have seen that what are some pressure test requirements. We have seen how leak testing would be carried out. We have also seen that how soil resistivity would be fine, what would be the criteria for inspection of buried piping. Now we'll go towards section 12, that is how to identify the minimum required thickness. Now, minimum required thickness of a piping system can be due to multiple parameters. You can have thickness required to maintain structural integrity. You can have the thickness required for sustaining the pressure inside the pipe. You can have the thickness requirement based on whatever corrosion that is happening. So all of these things are going to determine what would be the minimum thickness required. ASME B313, which is in most cases going to be the construction code for the piping system, will give us some recommendation and some formulas to identify that how to identify the thickness requirements based on the pressure that is required. Okay, so we'll follow different criteria and finally we might receive a final thickness which we can consider to be as minimum design metal thickness that can help us to understand that what should be the remaining life of a component. Okay. So ASME B313 contains formulas and data for determining the minimum required wall thickness for new uncorroded piping. The specifications relate thickness, diameter, joint efficiency and allowable stress to identify the maximum safe working pressure. In specifying pipe for original installation, ASME B313 requires that the following shall be taken into account when the pipe thickness is determined: corrosion allowance, threads and other mechanical allowance, stresses caused by mechanical loading, hydraulic surge pressure, thermal expansion and other conditions, reinforcement of openings, other allowances. Additional thickness is nearly always required when item A through E are considered. That means some amount of extra thickness requires when the pipe is in original construction. So if the minimum thickness required is 20, we can try to make a pipe that is greater than 20, so whatever the unexpected metal loss happens in the future, our pipe would still be in service because that metal loss would not go beyond the minimum required thickness. Normally, engineer will select the pipe schedule that accommodates the required thickness plus manufacturing tolerances permitted by the piping material specification. Additional thickness is often needed near the branch connections. This additional thickness is usually provided by one of the following: a welding T, saddle, internally reinforced branch outlet. A header or a run pipe thickness is greater than the required design thickness. Caution should be exercised in calculating the retirement thickness for the piping with branch connections reinforced per item. These calculations should be performed by a piping engineer. For in-service piping subjected to localized damage as well as weld misalignment and distortion, the inspector may choose to evaluate the piping strength and suitability as per the approach discussed in API 579.1 and ASME FFS1, that is fitness for service evaluations. Such analysis should be performed or under the direction of a piping engineer. Pressure design thickness. ASME B313 contains a formula for determining the required thickness of a new, uncorroded, straight pipe subjected to internal pressure. API 570 permits the use of simple Barlow formula. So this is a Barlow formula to determine the required wall thickness for in-service piping. ASME B313 provides the guidance of when other equations are applicable. The Barlow formula is as follows. This is Barlow formula where P is the design pressure, internal design pressure in the pipe, T is the required thickness, D is the OD of the pipe in millimeters or inches, S is the allowable stress at the design temperature, and E is joint efficiency, okay, longitudinal quality factor. The Barlow formula gives a result that are practically equivalent to those obtained by more elaborate ASME B313 formula, except in the cases involving high pressure where thick wall tubing is required. Metallic pipe for which T greater than or equal to D by 6 or P by SE greater than 0.385 requires special considerations. ASME B313 also contains allowable unit stress to be used in the formula contained in that publication. These allowable stresses include a factor of safety and are functions of the piping material and the temperature. So we'll talk about this in a great detail when we look at the construction code of B313. This document is only intended to act as a supplement for 570. So again, this formula is telling us that you should go to the original construction code and the recommendations are given there. Structural minimum thickness in low pressure, low temperature application, the required piping thickness is determined by a simple Barlow formula and can also be can be so small that the pipe would have insufficient structural strength. For this reason, an absolute minimum thickness to provide sag, buckling and collapse at the support should be determined by the user for each size of pipe. The pipe wall should not be permitted to deteriorate below its minimum thickness regardless the results obtained from the B31.3 or Barlow formulas. The owner user should specify how structural minimum thickness is determined. Example is given in table 7 to identify how much is the alert thickness. The piping diameter greater than 24 inches, temperature exceeding 205 degrees Celsius for carbon and low alloy steel, higher alloys that is carbon steel and chrome moly, spans in excess of 20 feet, high external loads, excessive vibration, engineering calculation typically using computerized piping stress analysis program. This is basically piping stress analysis may be required in this instance to determine the structural minimum thickness. Minimum required thickness. Generally, the piping is replaced or repaired when it reaches the minimum required thickness unless the fitness for service analysis has been performed, which defines the additional remaining life. The minimum required thickness is greater value of the pressure design thickness or structural minimum thickness. Following steps should be followed when determining the minimum required thickness at the CML. Step 1 is to calculate the pressure design thickness rating per code. As per the code, determine the minimum structural thickness as per the owner, user or engineering calculations. Select minimum required thickness. This would be the larger of the two. Either if you get two values for the thickness, the larger value will be taken into consideration. Both of these criteria, either one is going to be according to the pressure and other is going to be according to the structural requirements. For services with the high potential consequence of failure were to occur, the piping engineer should consider the increasing the minimum allowable thickness above the one determined above the step 3. This would provide the extra thickness for unanticipated or unknown loading, undiscovered metal loss or resistance to normal abuse. There is an example given that how you should identify the thicknesses if the pressure is given, and again opposite can also be done. If the thickness is given, you can also understand that how much it would be the pressure sustained by that thickness. Minimum alert thickness. The user may establish a minimum alert thickness with the values greater than either the minimum structural thickness or pressure design thickness, whichever governs the minimum required thickness results. Alert thickness is often inputted into facilities inspection data management program. The alert thickness signals the inspector that it is timely for the remaining life assessment. This should include the detailed engineering evaluation and structural minimum thickness. Fitness for service assessment or developing a future repair plans. In addition, where the CML reaches the alert thickness, it flags considered the extent and severity at other possible locations for corrosion mechanism. Alert minimum thickness are usually not intended to mean that the pipe component must be retired when the 1 CML reaches the default limit. Table 7 shows the example of minimum thickness for carbon and low alloy steel pipings and should be used in conjunction with the default minimum structural thickness. So here it is given that what should be the minimum alert thickness for carbon and low alloy steels. Valve and flange fittings. Valves and flange fittings are subjected to stress both from internal pressure and from mechanical loadings and temperature changes. Valves are also subjected to closing stresses and stress concentration because of their shape. These stresses are difficult to calculate with certainty. For this reason, the thickness of the valves fittings are substantially greater than the simple cylinder. So the valve body is generally greater in size. The ASME B16-34 establishes the minimum valve thickness at 1.5 times and 1.35 times for class 4500. The cylinder thickness for the simple cylinder design for the stress of 7000 psi and subjected to internal pressure equal to the pressure rating for valve class 150 to 2500. Actual wall thickness requirements is given in table 3 of ASME B16-34 and are approximately 0.1 inch thicker than the calculated values. Valve furnished in accordance with the API 600 have thickness requirement for corrosion and erosion in addition to those given in B16.34. Okay. The formula for calculating the minimum required thickness for a pipe can be adapted for valves and flanges by using a factor of 1.5. So whatever is the thickness is given in ASME B31.3 for pipe, multiply that by 1.5 and that would be the thickness for the valves and fittings, this can be used. Okay, so the same Barlow formula is used, but 1.5 is multiplied to it. This calculated thickness will be impracticable for structural standpoint. Therefore, the minimum thickness should be established based on the structural needs. So this is the pressure reading. If you require the valve as per the structural consideration also, then some additional calculation needs to be done. For piping, stress analysis needs to be done. The calculation described above do not apply to welded fittings. The calculation for the pipe can be applied to welded fittings using appropriate correction for the shape if necessary. Okay, so this was all for section 12. In the next video, we'll go for section 13, which is going to be the last section for API 574 code.